Hey folks, Mark Allen, BHSpringSolutions LLC and BHSpringSolutions.com. We're back for the summary of the initial observations contained in this inspection about the Springfield SA-35. And again, I want to re-emphasize as we start this summary that at this phase of our review, there's absolutely no way to come to any determinations. Is this a good pistol? Is this not a good pistol? Is this thing going to, fracture and fly away? When we start, putting it under stress and we start doing some of the things that we do to handguns during our testing, we call extreme testing. But that's what we're doing this all to find out. At BHSpringSolutions, we feel like we've gotten a little more sophisticated in about the last 3.5 years since we 8,400 round tested the TISAS Regent BR9, and we're taking a little more, we hope, sophisticated approach to the testing of the Springfield SA-35. We want to really pay attention to some of the things in the initial observations contained in this inspection. I'm going to read some of it here. This is also available at BHSpringSolutions.com. Take a look in either our BH Knowledge Base or High Power University. At 5 5/8 pounds out of the box trigger brake weight, the SA-35 is probably the lightest out of the box high power trigger brake weight ever sold in a production high power. In the SA-35 that we're testing, the trigger reset is somewhere between satisfactory and respectable. However, due to the tight tolerances of the high power's traditional trigger subassembly design, strict adherence to these production tolerances is required to avoid some SA-35s feeling like reset is insufficient. So we want you to know that what we're speaking about is we're speaking about this one Springfield SA-35 and our experiences with it. The traditional trigger subassembly in the high power pistol is a extraordinarily tight tolerance proposition, both to manufacture and to fit, and sometimes to function. So what we can say about this one, however, is this is a respectable trigger reset. Is it as great as what you can have in a high power? No, probably not. However, out of the box, this is a whole different proposition than an 8.5, 9 pound trigger pull that we were all accustomed to out of a FN or a Browning. So, to Springfield, they addressed an annoyance for a lot of high power owners in their high powers when they got them out of the box. And this pistol does not have such extreme downsides as far as the trigger itself and the trigger's action as far as reset. And so we can say that Springfield, they were thinking, they did some work where this is concerned. The SA-35 trigger has no provision for a magazine disconnect device. So there is no magazine disconnect. Total trigger travel is longer than is possible with more modern design BH Advanced trigger subassembly for high powers, plus the positively positioned BH Type 1 safety sear lever with spring for high powers. Over travel past the break point is noticeable when the trigger is held after the break and the slide is pulled rearward. The Type 1 floating steer lever does necessitate this. I'm going to do some demonstration about what exactly does that mean and what are we talking about, because while it's accurate and we've explained it exactly the way we want to explain it, it is an awful lot of terminology that you have to be familiar with, or it just starts to run together and you start to think, what are they saying about this? So we're going to demonstrate here in a second. Trigger resets after approximately 80% of the trigger's full range of forward travel. What we're saying here is that with some of BH's advanced components, particularly replacing that floating steer lever with a positively positioned sear lever, both for safety purposes and for function purposes, and also replacing the entire trigger subassembly with a BH Advanced trigger subassembly for high powers. It is possible to decrease the total amount of the trigger travel. The total amount of the trigger travel you can judge by pulling through the take-up on the high power, through the brake. But now I want you to watch my finger here as I clear the trigger lever and the sear lever. Watch the finger. You see it moved. Okay, that is called over travel. Over travel that happens after the break, when the whole explosion thing happens and the recoil is what's going to be your focus, and you're finger is still pulled rearward, that over travel at that time is pretty imperceptible. It's pretty tough to even feel it when the whole gun just rocked your wrist and your arm and you're controlling the recoil. However, the reset, which is that, what you can see is that's quite a bit of trigger travel when you add it all up. The take up, that's very reasonable. The brake also is reasonable, but then you have this additional travel, and that creates your full reset. The reset happens at about the 80% point of the forward travel back forward. That's fine. However, with more advanced parts, you can better what this is. Now, that is not to say that this is bad. I personally, trigger travel that moves after the trigger brake after this point, it creates for me a little bit of a timing challenge in when I start rapid firing, because the amount that my finger travels before the explosion, my reflexes recognize and understand that. However, the amount that my finger moves after the explosion when that slide first starts rearward, that part my reflexes don't handle as well. So it winds up feeling like I've got a longer reset than I have trigger pull. And when we put in advanced parts, which we'll be seeing later, one of our objectives and one of the things that is possible is to put all of the trigger travel on the front end, meaning that all the trigger travel is contained in the take-up and in the brake, and you have no perceptible like that over travel, and then your reset. And without having the over travel, the reflexes, when operating rapidly, tend to interpret this travel better than travel that happens simultaneously with the explosion and the slide starting rearward, and then trying to time backwards from there. So we'll be getting to that. However, we want to acknowledge one thing. Springfield did set this up because they are using that floating Type 1 sear lever. This over travel that I'm showing you here now, this is necessary. It is the only safe way to set up a Type 1 sear lever high power. And I want to say that again. Any guys who are going to modify these, any guys who are going to customize these, any guys who are going to be working on these, if you do not replace out that floating sear lever, you need perceptible over travel to get that trigger lever up high enough, because you don't know where that sear lever is coming back and going to contact that trigger lever. You need that amount of over travel that you see right here. And we'll be getting to what is a positively positioned sear lever, what's BH done for that, so that we can get that trigger travel, the finger travel, all on the front end and virtually eliminate the over travel that we see here. However, Springfield did a nice job with this setup, considering the parts that were chosen. It's the older design parts, and they're fine as long as they're set up well. So congratulations to Springfield for how they set this trigger up specifically, and acknowledge that you should have a safe floating Type 1 sear lever, if there is such a thing, because they have done it so that you have that absolute, there is over travel past the trigger brake when the slide moves. You want to see that. Slide to frame fit, it's about average for high power pistols. This is not a fits like a tight glove slide to frame relationship in the SA-35, nor should it be. Likewise, the frame and slide relationship are not too loose or too sloppy. High powers that have frame and slide relationships that are over snug, or they have that fits like a glove element, when these are shot in rapid manner and over the course of several magazines, that type of a frame slide relationship will usually have slide and frame seize up mid-cycle and stubbornly stay that way until the steel cools back down. In other words, in a lot of the traditional, what we would call high-end customizing work that's been done on high powers, they work for a slide and frame fit that are like Lycra pants, basically. And that is fine, and it's impressive for a minute until you get to about your third magazine or your fourth magazine, and all of a sudden your slide and your frame, because steel expands and contracts, and more than you think, more than I ever thought. And if you don't have, that's your margin. That's your margin for slide and frame to expand, because they're going to. These parts get red hot almost, and too hot to touch. And as you're going to see in some of our extreme testing, we won't be able to touch this slide and frame without gloves, or attempt to take them apart without gloves. And this margin that they have made in the slide frame relationship, a lot of people will say, oh, that's too much. No. They've done a good job here. You have to have this, or you won't get very much round count out of them before the slide starts rearward, and it'll get someplace about like this. And why is it usually here where they seize up? Because if you're going to notice, the slide comes rearward, encounters the hammer, and that hammer is actually pushing up on the slide now. The slide's also pushing down the hammer, but the hammer is pushing upwards on the slide. So everything starts to get tight into this area, and usually when they seize up, they'll seize up somewhere about like that, and you can't move that slide and frame when that happens. It'll move all by itself. Just let it cool down and set it in the shade for a minute, and for a lot of minutes. Usually when that cools down, all of a sudden that slide will slam back forward, and it'll magically just work like new again, usually. But anyway, we wanted to talk about this, and also just have a little education about this. That's a nice slide to frame fit. It is not over sloppy, it is not too loose, and at the same time it is not too tight, and you can be either way of optimal. You can be too loose, you can be too tight. Either one of them has their downsides, and we can say that that Springfield has done a nice job with the slide to frame fit here on the SA-35. The SA-35 is of the same design as the FN Browning high power, but various things about the SA-35 do not conform to FN Browning production, and that's what we've detailed here in this report. The SA-35 likewise does not seem to perfectly conform to any other manufacturer's production either, so it is assumed that the SA-35 is a reverse engineered handgun based on, but not necessarily conforming to, the classic FN Browning high power design. The nearest cousin, high power, to the SA-35 would be the TISAS BR9. However, the SA-35 contains multiple components that do not conform to the components that were found in the BR9, and so far we see that positive in every way. Comparisons, and we wanted to make sure that we say this, because we have found several comparative things to the ways that the Springfield SA-35 seems to conform to the TISAS Regent BR9. So before anybody starts saying, oh, it's a TISAS, or whatever, no, there's several things that do not conform to the TISAS BR9: the firing pin retaining plate, the extractor, the sear pin, and that's the trigger subassembly performance. All of these things, really legitimately make this a different gun. So, whether it's taking design cues from TISAS or not, we're evaluating this as a Springfield SA-35. However, we are going to show, things that conform from a design standpoint between previous generation high powers and the Springfield SA-35. But we wanted to say that comparisons made to the TISAS BR9 are chronologically incidental by virtue that the TISAS BR9 was the last new gun high power production that existed in the market prior to the Springfield SA-35's entrance, and some similarities to the BR9 that do exist in the SA-35 are, to an extent, already known design aspects. However the lineage of design happened that culminated in the SA-35, it is worth noting that the Springfield has specifically steered clear of many of the pitfalls that ultimately caused the TISOS BR9 to need replacement of so many of the internal components. Superior design work is found in the SA-35 compared to the BR9, specifically in the extractor, firing pin, retaining plate, and the sear pin. Okay, we're going to run to another subject, and that is hardness of frame, slide, and the internal, what we call impact parts in the Springfield SA-35. This is all available at BHSpringSolutions.com in print form. Look at the BH Knowledge Base or High Power University, and you'll be able to print this out or read it there on your screen. But before we did anything with this Springfield SA-35, and before this point, we did have frame, slide, and internal components, most of the internal components hardness tested. I'm going to show you some evidence of that. You can see right there, if it focuses in, that's a tiny hole in the metal, and that hole was made by a diamond on the end of a Rockwell hardness tester. And we have those. Actually, this one was for testing not the frame, but the frame's locking lug cam, which you see kind of like a crossbar there that goes all the way through from side to side in the frame. And then we tested the frame in 2 or 3 places, particularly places under the grip was a good place for testing those. You'll see evidence of one of the test marks on the slide right there. And then we have another one up here. So frame and slide we tested in multiple places, and we did develop a very tight range of indicated values of the hardness of the steel in the SA-35's slide and frame. This was an important milestone and an important test for BHSpringSolutions, specifically for one of our primary objectives of this analysis and testing. In other words, if we don't get past the hardness test, or if for some reason we see that frame and slide are not acceptable to us in order to build a BH Advanced Masterpiece out of this foundation of this frame and this slide, our testing really stops here. But that's not what happened. And this is important from this point of our one of our primary objectives of evaluating suitability of the Springfield SA-35 as a platform for the BH Advanced Masterpiece High Power Series. That requires a hardness of frame and a hardness of slide that we deem to be compatible with the product that ends up being. We can say for sure that the hardness of frame, hardness of the locking lug cam in the frame, which is a part that is intended to be mounted permanently and based on how it's installed into the high power, and the slide itself. We can confirm Rockwell hardness amounts that are consistent with what we would expect and have seen and would see when hardness testing FN Browning frame, locking lug cam, and slide. And about this one Springfield that we're doing this analysis and this testing on, we can say conclusively this is conforming to what we have become accustomed to working with in the FN Browning manufactured high powers. Good stuff. We were very, very, very happy to see that. Other components that we tested: barrel, extractor, ejector, firing pin retaining plate, sear lever, slide stop, and hammer. We go into quite a bit of detail about the conclusions, and that goes for most of this page and the next half a page. And this gets very, very detailed. And the essence of what this all concluded is Springfield appears to have embraced a strategy that sees them hardening all of those internal components barrel, extractor, ejector, firing pin, retaining plate, sear, lever, slide, stop, and hammer to a lower hardness level than we would see and have seen and would expect to see in the same FN Browning parts, or if we're talking about hammer, BHSpringSolutions, our SFS system has a hammer, our SFS system has a sear. FN Browning made a traditional operating sear. We make the SFS sear, which is a different part. We would see higher degrees of hardness in all the SFS parts and in all FN Browning OEM parts. Now, having said that, I want to just stop the wheels turning and anybody listening to this here just long enough to take in what we're going to say about this. Because, yes, you can say, oh, well, the parts in the Brownings are harder than the parts in the Springfield. Yes, they are. Now, stop right there, because the whole conversation is never that simple, and it's definitely not that simple in this case. Let me explain to you why. Just as a generality, we were in the mid to upper 30s HRC, hardness, Rockwell, C-scale, on most of these, all of these, except the barrel, Springfield internal parts that we measured. We would typically see measurements that would start around 42 or 43 at the low and go up into the low 50s for virtually all of these parts. Every part in the high power pistol has a best acceptable Rockwell hardness range, or that the different manufacturers have decided to harden them to. What we wanted to see is, what are the parts hardened like in the Springfield, and compared, on purpose to what we would see and have seen and would expect to see in the FN Brownings. Yes, they're softer. Here's the punchline to this, though, folks. Every manufacturer of the high power at one time or another has had a problem with this part, the firing pin retaining plate. Virtually every manufacturer has had that part fracture, and making it a limited life part, an unpredictable part. It's getting hammered by the hammer's mainspring. Every time that hammer comes forward, it just slams that part, and it's a heavy mainspring in the high power pistol. We can produce that part to mid 50s to 60 and even higher Rockwell hardness, but the harder we make it, the more likely it becomes you're going to fracture that part the first time you go to the range. Maybe the first time, and if we get it hard enough, we'll fracture it the very first time it's hit with a hammer at all. So hopefully that stops anybody from, running out and going, oh yeah, they tested it, the Browning parts are harder and, that's better. And well, sometimes, but sometimes it is not. And this is a part that is an example. Over hardening this part results in fracture. Now, the implication of this part fracturing, by the way, as you take a look at it right into the camera lens, imagine looking right down that sight, lining up the front sight, and you're looking straight down that sight picture, right? Look where that firing pin is pointing, and it's got a spring behind it. And if that firing pin retaining plate is all of a sudden not there, or its integrity is lost, you see where that firing pin is aimed at? Yes, exactly, right at your eyeball. And it's probably going to be a pretty good shot on the part of the firing pin retaining plate if that happens. This is the implication of this part. This is not a joke, folks. This part fracturing is real serious business, and this is a real serious subject. Of all of those parts, with the exception of the barrel, all those parts that we tested, the firing pin retaining plate was the lowest hardness. And I have to tell you, we don't know what happens with internal parts for high power pistols when they're hardened into the low 30s, mid 30s, upper 30s. We don't have experience with it. Our chief weapons and modifications designer, Leon Hubert, has no experience with high power parts hardened to this level. But this is an on purpose strategy on the part of Springfield to avoid some real bad places, frankly, that the TISOS Regent BR9 ended up going to with its fracturing parts. This is a legitimate, purposeful, strategic decision of how they've hardened their parts. And I'm encouraged on the front end that we can test this firing pin retaining plate, and we can test it a lot, and it's going to maintain integrity. Now, the flip side of going with a softer hardness rating, obviously some parts when they're made softer are going to have a shorter service life. How much, we do not know, but that's an obvious logical certainty, especially when you have parts like hammer tooth and sear that are pressed. Both of them are pressed toward each other by a spring, and they have to be forcibly disengaged from each other every time that trigger is pulled. Are these parts going to wear faster if they're hardened to a softer value? Yes, they are going to wear faster. Yes, they're going to have a shorter service life. That is logical. How much shorter, we don't know. That is yet to be seen. What I can tell you is this, is that our chief weapons and modifications designer, Leon Hubert, did not get, how do I say this, did not get over concerned about the Springfield SA-35's parts hardness levels as we measured them. He actually said he's okay with them. However, how actually we used some of his wording, and I'm actually going to just read that to you here. Leon Hubert's words and his conversation back with us about the hardness testing that we had performed and the values that came back. His analysis was this: it is very difficult to assess the loss of efficiency of the different parts due to a lower hardness. And as a side note, he said it could also be those hardness readings could also be due to material of less good quality. But it is obvious that there will be a shorter life for some parts. And we cannot stress enough that all of these parts are rather easily replaceable. So again, this is, I think, partly the reason Leon Hubert understands that some parts in the high power have had at times a reputation for fracturing, for failing, and that's not good, and that's never good. A catastrophic failure of a part in a handgun or in any firearm, that's just like a no-go zone. You just do not want to be going there very often because that's bad. Parts that need to be replaced, on a schedule, just like changing your oil, that's part of maintenance of any machine. That's part of it, and it's highly preferable to parts that fracture. So we don't want the message to be lost because the thing that we can definitely identifiably say is Springfield has a strategy here. They've not gone into this just heat treating their parts up to whatever happens and then throw it together, and it did nothing like that. No, this is the readings that we got were of a consistency and all at a level that we can see that they have put some real thought behind this. Do we know is it good? Is it bad? What we know for how those different parts work and what they tested at is they should work. If there's going to be a strategical deviation away from the levels that hardening levels, for example, of FN or Browning, you don't want to go the wrong way with that. In other words, the wrong way would be over hardening and having stuff fracturing and metal flying all over the place. That is not what happened here. And so please understand, that's good. And the hardening is at a level that should not be causing any malfunctions, and hopefully is going to put the Springfield SA-35 farther away from the outcomes and the experiences that happen with a lot of owners of the TIS Region BR9. Because going softer on the end hardness, that is a strategy that should have parts be brittle. So, from that standpoint, we're very, very hopeful. And throughout all of our testing, we are purposely going to be conducting all of our testing unless we have a failure, unless we have a fracture, unless the extractor stops passing our shake test as we're proceeding through the testing. The firing pin retain plate, extractor, and ejector, these parts will remain the Springfield SA-35 parts unless we have a reason to change them, unless there is some kind of a failure. Okay, we wanted to point you to one other item, and this is all about this hardness question that basically BHSpringSolutions has created here because we understand what hardness numbers we normally see in FN Browning parts and our own parts, and we got a significantly lower degree of hardness readings out of the Springfield SA-35 internal parts that we tested. And, we are conscious that questions about this, are likely not to go away anytime soon because this is something different. And even though it doesn't shake us up, at BHSpringSolutions, that is not going to probably be enough for a lot of users. So what we did is we came up with some suggestions for users of Springfield SA-35s who expect this to be a high round count handgun. In other words, you're going to be shooting it a lot, and you're planning on shooting it a lot. And what does this, softer degree of hardness mean? What should you be looking for? And we came up with some suggestions for this. And also, along with this, well, what about high powers that are not going to be necessarily high round count high powers, but are going to be shot some, or whatever. These are good guidelines and suggestions, for you as well. But I wanted to point this to you. If an SA-35 owner intends for his SA-35 to become a high round count SA-35, upgrade of numerous internal parts would be a good thing long term. That's one suggestion that we're making. However, we're not saying you got to, necessarily run and replace anything. We're going to show you what we're doing with the SA-35 that we're testing and what our results are like for a lot of different components that we're going to be testing throughout this evaluation. At a minimum, high round count SA-35 users should own a trigger brake scale and monitor the SA-35's trigger brake over time. This would be one early warning indicator that excessive parts wear may be happening, or that the components in the springs setup may be nearing the end of their useful life. Any reduction in trigger brake weight readings that go below 4.5 pounds should be investigated and corrected. Now, the reason we're saying that is because you get below 4.5 pounds. Remember, this is 5 5/8 out of the box. Just fine. However, with the parts that are OEM in the Springfield SA-35, trigger brake weights below 4.5 pounds are getting on a razor's edge of firing when you rack the slide or running full auto or more than one round coming out of the barrel per trigger pull. So that's a benchmark. If over time you start seeing that trigger brake weight declining and you see it go to 4.5 or into that neighborhood, into that range, you're getting into an area where there's not enough pressure on the sear, keeping it stable enough. It's taking too little force to trip the sear and the hammer tooth relationship, and you need to be finding out why, and you need to be correcting that. Also, understanding the BHSpringSolutions high power extractor shake test and testing the SA-35's extractor in this way periodically would also be a good practice. We're going to show you exactly right here how to do that, and may give early warning that the softer SA-35's extractor claw may be nearing the end of its useful life. So what we mean by that when we say shake test is take a cartridge and slide it just behind the extractor claw. And if you don't know where that is, your extractor claw is right there inside your ejection port in the slide. You're just going to slide a round behind that extractor claw, turn the slide over, and shake it just moderately. You're not trying to shake it out necessarily. That's pretty good shake force I'm using right there, and I'm not getting any wobble in that cartridge. That extractor is holding and it's passing the shake test. Generally speaking, extractors that pass the shake test that I just showed you do not fail to extract, do not fail to hold on to the cartridge casing long enough to get it to the ejector, which is this part right here, and there's your engagement area of the ejector. Your empty cartridge casing begins rearward, held by the extractor, hits that ejector, and it flies out of the ejection port of the slide. That's how your extraction works. So knowing the extractor shake test and periodically checking it. That extractor claw, that is a wear part area. It has lots of metal-to-metal contact in its life when it's doing its job, and a softer extractor claw, could it wear out sooner? Maybe, maybe not. How many rounds? Nobody really knows. However, it will be a slow process when it starts wearing out. If you start to see wobble when you do that shake test, that would be a red flag that probably it's time to replace that extractor. Otherwise, if it's passing the shake test, it's nothing you need to be worrying about. Another thing that every SA-35 owner should keep an eye on: the distance that extracted empty shell casings land on the ground from the shooting position of the handgun. And then we suggest learn about slide velocity synchronization in the high power from BHSpringSolutions and use spring setups that result in extracting empty shell casings consistently landing in the 4 to 10 foot range away from the shooting position. So these are just some suggestions that we've come up with that, if you just shoot your Springfield SA-35 completely stock and it's a high round count handgun, or you do any degree of modification to it, these are good guidelines that will often help you see in advance that something is, ending or getting near the end or nearer the end of its useful life as a component. Okay, that's enough about that. Now we're going to get into our test protocols, just a preview of this, and then the next thing we're going to be doing is we're going to be seeing some shooting, some testing, and some results of that. This is the beginning of BHSpringSolutions test protocols in the Springfield SA-35. We are saying that prior to test firing, the SA-35's floating sear lever is going to be replaced with BHSpringSolutions Type 1 safety sear lever with spring for high powers, to add additional margin of safety in the Type 1 sear lever design, specifically with respect to when any internal parts contact the sear and when they do not. Also replaced will be the firing pin spring, and we're not going to test with the light firing pin spring of Springfield's, but we will be using BHSpringSolutions heavy firing pin spring to add to the margin or degree of drop safety protection in the SA-35, since the design does not contain a mechanical firing pin block for you 1911 guys, or drop safety. You 1911 guys, you think of this as a Series 70. And the firing pin spring does essentially the same job. And we want you to understand why we're not going to be testing, with Springfield's parts in the pistol right out of the gate. And the reason is because BH Spring Solutions has advanced these components, specifically a positively positioned sear lever. It is a safer design. It has elements and margins of safety that are higher than a floating sear lever that is randomly floating and hitting the sear when it does, as well as the firing pin spring. We are intending and planning to be firing thousands of rounds. And because BH Spring Solutions has advanced design in those specific parts, and these are margins of safety for us in our testing, handling, shooting, firing of the handgun, from our position to have additional margins of safety and not use them is stupid, because there is no such thing as a risk-free 2,000, 3,000, 4,000 rounds of firing a handgun. And so for that purpose, for that reason, for myself and for all of our personnel and any who will be firing the handgun, we are going to be adding margins of safety and keeping this the safest proposition possible. Anything that we will be changing out, we will be letting you know, and we're going to be showing you the actual change out of the component and how to do it, how we're doing it, and why we believe it adds margin, or why we know it adds margins of safety to the handgun that we're going to be working with. Folks, thanks for watching this session of High Power University. This is the special series in High Power University about the Springfield SA-35 and BH Spring Solutions evaluation of the SA-35, and for the primary purpose of determining compatibility with BH Spring Solutions advanced high power components, and to evaluate suitability of the Springfield SA-35 for use as a platform for the BH Advanced Masterpiece High Power series of super premium high power pistols that we do. So these are, again, our primary objectives, and by the time we have finished testing, we intend to answer all questions for both of these primary goals that we have set out here in the beginning. Thanks for watching, folks. I'm Mark Allen, BH Spring Solutions LLC, and BHSpringSolutions.com.